Further Mathematics, Paper 2. May, June 2015. We have question 1 here, and we are going to solve all of them, and we shall look at the mistakes that your predecessors did and what you should avoid so that you can score more marks in this year's WASSCE. A binary operation triangle is defined on the set of real numbers R by this: A triangle B is equal to A cubed minus B cubed. Without using a calculator, find the value of this: root 3 plus root 2 triangle root 3 minus root 2. Leaving your answer in set form. Now, this means you should leave your answer with a square root sign in it. So let's look at how we can solve this. Now, this is the definition given to us. So we just solve in. Wherever we see A, we put root 3 plus root 2. And wherever we see B, we put root 3 minus root 2. So we did that, and that's what we are going to get: root 3 plus root 2 all cubed minus root 2, root 3 minus root 2 all cubed. Now, according to the chief examiner, most students were able to do this one correctly, but a few of them were not able to manipulate this. So they lost mark over there. So I don't want you to also repeat the same mistake. So let's look at how, or the trick that they could have used is this. You know, this is now a binomial expansion. They are almost the same, but except in sign. So recall that if you have A plus B cubed, you get this. And A minus B cubed, you get this. So we just apply that knowledge over here. So we have root 3 plus root 2 cubed will give us this: root 3 cubed plus 3 root 3 squared plus 3 root 3 square root 2 plus 3 root 3 root 2 squared plus root 3 root 2 cubed. So that will give us that, and this also give us this. This will give us this. So just by substitution we get that. Now the next thing is to simplify. So we know that root 3 cubed will give us root 3 times root 3 times root 3, and that will give us 3 root 3. Then the square will cancel this to give us 3 over here. This one will give us 2 over here. So the same thing is repeating over here. Now we move on further. This will be 9, 3, 3, 9, then 3, 2, 6. The same thing applies over here, negative 9, then positive 6. So the only thing you have to do here, this question is so simple, is to expand over here before the rules. Is very simple if you know what you are doing. So we expand negative 1 over here and positive 1 over here, we get this expansion. So this now becomes minus, and this becomes positive, as plus, this becomes plus again. So now look at something. The thing is so simple. This will cater for this. So you get 0 there. It's also cater for this. You get 0 there. So we are left with this 9 root 2, 9 root 2, then 2 root 2, then 9 root 2, then 2 root 2. And that will give us 9 root 2 plus 2 root 2. And when you simplify this, we get 11 plus 9, that's 19, that's, so this will give us 20, 22. 22 root 2. Question 2. Points 2, 1 and 6, 7 are opposite vertices of a square which is inscribed in a circle. So a square that is inscribed in a circle. We are supposed to find the center of the circle, then the equation of the circle. So let's see how we can do this. So this is the diagram. We have a circle that is inscribed. We have a square that is inscribed in a circle. And these are the vertices, the opposite vertices. Someone can decide to put them here and here, it doesn't matter. Now this is the center. We don't know, and so we should find the center of the circle. So, you know, since this is a diagonal and it is touching two sides of the circle, it is the diameter of the circle. So we can find this, the midpoints of these 2 points will give us the center. So to find A, we know if we add 6 and 2 divided by 2, we should get A. And the same thing applies to the B2 using the midpoint theorem. 1 plus 7 divided by 2 will give us the coordinates of the center. So our center now is 4, 4. So we have the center 4, 4. We can use the center with any of these points to find the radius, because say we find the equation of the circle. So if we know the center, we need a center and a radius, or 3 points on the circle. But now we know only 2 points on the circle, so we need to find the radius. So distance between C and B, C and any point can be found using the distance formula. So we have the radius to be equal to 4 minus 2 all squared plus 4 minus 1 all squared. Now, this simplifies to give us root 13 units. So according to the chief examiner on this question, most students were able to find the center. They did very well. Now the only problem is the B aspect, that they were not able to do well, and the equation of the circle. So now we know the center and the radius. So center is 4, 4 and radius root 13 units. So we use the formula x minus a squared plus y minus b squared equal r squared. So we're solving these values 4, 4 and root 13 over here. We get something like this. And when we simplify or we expand the bracket, we get something like this. So if you expand this, you get this. And if you expand this, you get this. Then this will give us this. So we can simplify further by grouping like terms and equating everything to 0. To obtain this equation of the circle, x squared minus 8x minus 8y plus 19 is equal to 0. Now you could have also approached it a different way. You could have represented this over here. This will be x, y, an arbitrary point on a circle, and this is the diameter. So you can use the diameter, this being the ends of the diameter and these points, and you know the multiply. If you multiply this gradient should give us -1. So you could have also approached it that way. I think this is easier for us to do. Question 3. Now, beyond this question, if f prime prime of x is equal to 2, then f prime of 1 is equal to 0, and f of 0 equal -8, find f of x. So we are looking for the function f of x. And this question could also be put in a different format if the 2y dx squared is equal to 2. The y dx at x equal 1 equals 0. And y of 0 equal -8. Find y. So that is it. According to the chief examiner's report, even though this question was very popular among the students, they displayed a poor knowledge of integration. So it means the student did not do well integrating a function or performing the integration to arrive at the function. So we have this f prime of x. This is where the function is, contains a variable x. So that is what we are going to integrate. So if you integrate, this means we have the 2y dx squared. So if you integrate that, you get the y dx, which is f prime of x. Then over here is the constant. So the exponent of x over here is 0. So you know integration, we add 1 to the exponent. If you give us 1, so you get x to the power 1 divided by 1. That will give us 2x. So plus the constant of integration. If we integrate this, we reduce the differentiation by 1 order. So that gives us this. Now, when given that f prime of 1 equals 0, f prime of 1 being 0 means that if x is equal to 1 and we plug in into this function, we are going to get 0. So we have x equal 1. Whenever we see x, we put 1 like that, and we get this. But we know that this f prime of 1 equals 0, so we start being 0 over here. Then we solve for c to be equal to -2. Now let's go back here and replace the value of c, which is -2 here. Then we obtain this function now. So we are looking for f of x, not f prime of x. So we have to integrate this again. So this is a differential or different derivative of the first order. So if we integrate it, we are reversing it. So if we reverse this, we go back to f of x. So if we take the integral of f prime of x, we get f of x. Now if we integrate 2x, see there's to the power 1 over here. So 1 plus 1, we get 2, then divided by 2. Then if we integrate 2, we get 2x plus k. That's a new constant, or a static constant k. So we simplify this to obtain this over here. Now the next thing we do is to sum in or use this initial value again. So we have when x equals 0, we put x equals 0 here, 0, 0. So we get something like this. Now f of 0 is equal to negative 8. So we sum it, we get this. So we find the value of k to be equal to negative 8. So we just substitute back into this function, the function that we are looking for. Then we get our function to be f of x equal x squared minus 2x minus 8. Question 4. Now we are solving tan 2x minus 15 degrees minus 1 equals 0 for values of x such that x is between 1 revolution. Now we have this, we make this the subject, or we send the 1 to the other side of the equation. In other words, we add 1 to both sides of the equation to obtain this. Now, when we are solving trig equations, you need to be very, very careful. So we take the tan inverse of both sides of the equation to obtain this. Now this is where the problem is. According to the chief examiner's report, most of the students were not able to get all the values that are required to score full marks. So most of them scored low marks on this, even though they did it correctly, but they couldn't find all the angles. So pay attention carefully to this analysis. Now we are saying that x is within 1 revolution, but we have 2x here. So 2 times of the x will be within 2 revolutions. That means from 0 degrees to 720 degrees. We are just multiplying through this by 2. So if that is the case, we must find the angles from 0 degrees up to 720 degrees. Now let's take this one first. Within 1 rotation or 1 revolution, we have something like this. We know if you are taking tan inverse of 1, because over here tan is positive in the first quadrant and in the third quadrant. So in the first quadrant, you are going to get 45 degrees. That is tan inverse of 1 will give us 45 degrees. Then in the second quadrant, you are going to get 180 plus theta degrees. That is 180 plus 45 degrees. Because we move from here up to here is 180. And this angle over here, this small angle over here is 45. So plus the 180 give us the 225. Now, so that will give us 2 angles within the first revolution, or from 0 degrees to 360 degrees. Now for 2x, it means we have to go another rotation again. So for the 45, we'll go and come back to the 45. So it will be like this. So we have made this again, so that is 2 revolutions. And that will give us 45 degrees plus 360 degrees, because we went 1 more revolution. So it will give us 360 degrees plus 45 degrees. Then we go again and come and meet this. Then that will be 225 degrees plus 360 degrees. So if that is the case, then we have a tan inverse of 1 being equal to the following angles: 45 degrees angle, that is this one, and 225 this, and 405 is this, and 585 is this. So the 405 divided this over here. Then the 585 is this over here. Now we therefore proceed to look for x. So we add 15 to both sides. So we are going to get 2x equal this 45 plus 15 degrees, or 225 plus 15 degrees, 405 plus 15 degrees, 585 plus 15 degrees. And now divide through by 2. We simplify this first, so we get a sense over here. Simplify this, we get this. Then divide through by 2 to get this. So you can see that all these angles are within 0 degrees to 360 degrees. So that's the value of x. So that is how the trig ratios behave. You have to be very careful about the arguments, especially when there's multiplication or division. But for addition and subtraction, the normal operation will cater for them. Now let us consider question 5. A car moving with an initial velocity u travels in a straight line with a constant acceleration of 3 meters per second squared until it attains a velocity of 33 meters per second after 6 seconds. Calculate the distance traveled by the car. So we have the following values. We don't know the u, that's the initial velocity, and we know the final velocity, which is 33 meters per second. Then we know the acceleration, we know the time. So we are going to apply the equations of motion to find the value of u. Then after that, we can use it to calculate the distance. So we know the equation v equal u plus at. So we solve in these values and make u the subject. Doing that, we get u to be equal to 50 meters per second. Now we can use any of these equations to find the value of s, that is the distance. So using the first one, we have s to be equal to this, and this will give us 144 meters.